Question 22. Ethanol and methanol form a solution that is very nearly ideal. The vapor pressure of ethanol is 44.5 mm and that of methanol is 88.7 mm at 20 degrees centigrade. A. Calculate the mole fraction of methanol and ethanol in a solution obtained by mixing 60 g of ethanol with 40 g of methanol. B. Calculate the partial pressure and the total vapor pressure of this solution and the mole fraction of ethanol in the vapor. इथेनॉल का वेपर प्रेशर गिवन है 44.5 मिलीमीटर एंड मिथेनॉल का वेपर प्रेशर गिवन है 88.7 मिलीमीटर. नाउ मिथेनॉल एंड इथेनॉल को मिक्स करके जो सोल्यूशन बना, we need to find the mole fraction of methanol and ethanol in that solution. Now weight of methanol that is dissolved is 40 gram and weight of ethanol that is dissolved is 60 gram. So moles of methanol, methanol is CH3OH, will be equal to weight divided by molecular weight. Weight given है question में 40 gram divided by molecular weight of methanol that is 32 gram per mole. Similarly, moles of ethanol, weight of ethanol given है 60 gram divided by molecular weight of ethanol which is 46 will give the moles of ethanol. Now the formula for mole fraction, अगर mole fraction of methanol find out करना है तो formula will be moles of methanol divided by moles of methanol plus moles of ethanol. So mole fraction of methanol is equal to moles of methanol. Methanol का moles कितना हो गया? Weight divided by molecular weight, that is 40 divided by 32 divided by moles of methanol plus moles of ethanol. Ethanol का moles कितना है? 60 divided by 46. 60 is the weight of ethanol and 46 is the molecular weight of ethanol. Solving, mole fraction of methanol is 0.49. Now the solution is of methanol and ethanol. So one of the components has the mole fraction, that is methanol has the mole fraction 0.49. Now for binary solutions, mole fraction of methanol plus mole fraction of ethanol is equal to 1. So mole fraction of ethanol will be equal to 1 minus mole fraction of methanol and this is equal to 0.51. Now B part, we have to calculate the partial pressure of this solution and the total pressure of this solution and the mole fraction of ethanol in the vapor. Now pressure of the solution is equal to mole fraction of methanol into pressure of pure methanol plus mole fraction of ethanol into pressure of pure ethanol. XA denotes the mole fraction of methanol, P0A denotes the vapor pressure of pure methanol, XB denotes the mole fraction of ethanol and P0B denotes the vapor pressure of pure ethanol. Putting the values and solving, जो total pressure आया that is 66.2 millimeter of mercury. Now the individual pressures, 43.5 is the partial pressure of methanol and 22.7 millimeter is the partial pressure of ethanol. So 43.5 millimeter is partial pressure of methanol and 22.7 millimeter is the partial pressure of ethanol and 66.2 millimeter is the total vapor pressure of this solution. Now pressure exerted by ethanol in the vapor state. For that the formula applied will be 1 by P is equal to x dash A divided by P naught A, where x dash A is for the mole fraction of methanol, P naught A is the vapor pressure of pure methanol, plus x dash B divided by P naught B. X dash B is the mole fraction of ethanol in the vapor state and P naught B is the vapor pressure of pure ethanol. Now we know that x dash A plus x dash B is equal to 1. So x dash A is equal to 1 minus x dash B. Putting the values, 1 by 66.2. 66.2 is the total vapor pressure and this is equal to mole fraction of methanol, that is 1 minus x dash B, divided by vapor pressure of pure methanol plus mole fraction of ethanol, divided by vapor pressure of ethanol, that is 44.5. Solving, the mole fraction of ethanol in the vapor state is 0.34.